Welcome back everyone to Basic Electronics classes. I am Lavanya Vaishnavi. Today I am going to take up module 4, which is BJT applications, feedback amplifiers and oscillators. This is session 4 and we will discuss about feedback amplifiers. Today I am going to cover the topics like introduction of feedback, what is positive feedback, what is negative feedback, comparison between these two feedbacks, and what are all the properties of negative feedback, how negative feedback is advantageous in amplifiers. Let us introduce what is feedback amplifier. What is feedback? Feedback is a process of returning a part of output signal from the circuit back to the input of that circuit. So it says that when you have a circuit with a feedback, we take a portion of output signal. If this is V0 is your output signal, we take only a part of it as a feedback. We will take it back to the input. Either we will add it or we are going to subtract it. So we will add it or we will subtract it with the input. Okay. So we are taking only a part of signal and giving back to the same circuit. We are giving back to the same circuit and this is called feedback. So feedback is defined as a process of returning a part. We are not taking the complete output signal. Instead, we take a single part, a minute part from the output signal of the circuit or the device and give it back to the input of the circuit. So depending upon the addition or subtraction, we decide whether it is positive feedback or it is negative feedback. That is VI. So this is VI. VI is the result of Vin and Vf. Okay, it is the result of Vin and Vf. So which is equal to Vin plus or minus. If I take plus Vf, then it is positive feedback. If I take Vi is equal to Vin minus Vf, then it is negative feedback. Both positive feedback and negative feedback have different applications. So depending upon the application, we will select what sort of feedback do we need for the circuit. I'll repeat it. Feedback is defined as it is a process of returning a part of output signal from the circuit to the input signal or to the input of the circuit. So based on addition or on the subtraction, we decide whether it is positive feedback or it is negative feedback. Next is positive feedback. What is positive feedback? So if I say it is positive feedback, then I have to add with your input signal, right? VF should be added with the input signal. What is VF? VF is the feedback signal. What is VI? Input signal. So Vin is the input to the given circuit. So Vi is the input for the amplifier. V0 is the output. Now, what is positive feedback? Now let me consider the input signal as a sinusoidal signal. Now, if I say input and output are in phase mean, so output is also a sinusoidal signal which is amplified. It means that, so if you have positive peak here, even at the output stage at the same phase you will be having positive peak. If you give sine as input, you will get sine as output. So this is in phase. Now, a part of output, that is a minute part of sinusoidal signal, is taken back as input as feedback and given to the input. Now this input is added, or the sinusoidal signal is added with the sinusoidal signal again, and this is amplified and taken at the output. So positive feedback is rarely used in amplifiers. We don't use positive feedback when we design amplifiers. We use positive feedback only in oscillators. We use it in only oscillators. Why we don't use in amplifier? Because when you use them in amplifier, suppose there is some addition of noise at the amplifier stage. It means that the output is also added with a noise. So you have a noise here. The same noise can be added to the input signal again. So the same noise is added to the input signal again. The same noise get amplified again. It amplifies again. It means the amplification of the noise will also be done. This means, so which is not a good phenomena or which is not a good sign. Therefore, it increases the gain. Of course, it will increase the gain, but it also increases the distortion, noise, and instability of the system. The stability of the system is reduced. The stability reduces here. Distortion and noise get increased. Therefore, positive feedback is not used in amplifiers. We use them in oscillators. Now coming to the gain. A is the gain of amplifier. This is the open loop gain. So without feedback, what is the gain I am getting? That is capital A. So this is open loop gain. And AF is closed loop gain. So with the feedback, what is the gain you are getting? So if this is complete system, if this is a complete system, what is the input for this? Vin. What is the output for this? Vout. So closed loop gain is Vout divided by Vin. So its value is equal to A divided by 1 minus A into beta. What is beta? Beta is feedback factor. Beta is feedback factor. So next is negative feedback. In negative feedback, we say that input and output are out of phase. Out of phase. That is, if I am giving a sinusoidal signal here, you will be getting minus sign signal at the output point. You will be getting minus sign signal at the output point. A portion of minus sign signal or a part of minus sign signal is given to the input, and this is subtracted from the input, and it is subtracted from the input. It means that you are reducing some part of the input and again you are giving for amplification. Because I am reducing here, so the gain is also reduced. So here you can say that the feedback is out of phase. The negative feedback is used in amplifiers. Okay, so here you have the point like the gain is reduced. The gain of amplification is reduced. It reduces the gain. But also it reduces the distortion, it reduces the noise, and it reduces the instability. It means it stabilizes the system. It will add stability to the system. It will add stability to the system. Okay. So it improves the bandwidth. We also get the bandwidth increased, and it improves the impedances like input and output impedance will also get increased. Sorry, not increased, it improves. So how does it improve? Depends on the topology what we take. So depends on what is the circuit I am designing. Accordingly, the input impedance and the output impedance improves. So if you want to make it higher, so according to the topology, it will work. Next is gain. So the closed loop gain is V0 by Vin, that is total output by the total input what I gave, which is equal to A divided by 1 plus A into beta. What is A? A is amplification factor of open loop system or open loop gain. Beta is feedback factor. Beta is feedback factor. So this is about negative feedback. Now let us compare between positive and negative feedback. So as I told you, in the negative feedback, so if this is your input sine wave, in a negative feedback, you will be having out of phase signal. That is, you will be having minus sign output. Here you will be having plus sign output. That is, these two signals are same and these two signals are out of phase. Okay. So because we decrease, that is, in the previous case here, Vi is equal to Vin minus Vf, right? So you are reducing the input, right? It means that the gain is decreased here, but here the gain is increased. So even though the gain is decreased, gain stability increases. In positive feedback, the gain stability itself decreases. The noise and distortions are decreased, whereas noise and distortions are increased. So it increases the bandwidth, here the bandwidth is decreased. So used in amplifier, application of negative feedback, it is used in amplifier. Application of positive feedback, it is used in oscillators. This is the simple comparison between positive and negative feedbacks. The next one is properties of negative feedback. What are all the properties that highlight the usage of negative feedback? So it desensitizes the gain. What is the meaning of desensitize? It makes less sensible. That is, the gain is less sensible to the changes in the parameters of the circuit. That is, if I assume that the amplifier has some noise in it and the output is also affected with the noise, and this affected noise will not vary the gain. The affected noise or the affected signal will not vary the gain. This is the meaning of desensitize. So the gain is desensitized. In a sense, the gain is less prone to noise and it is less prone to variation or distortions in the parameters of the amplifier circuit. This is what gain desensitization means. That is, the gain will remain constant. It will not change. That is what desensitize the gain means. Next is reduce nonlinear distortion. So the output, whatever the output is there, V0, we assume that it is a function of Vin. It is a function of Vin, and this function is linear. This function is linear. That means, so whenever the input varies, the output will vary linearly. It reduces the nonlinear distortion. That means, so the output will completely depend on a linear function of input. It will not depend on the nonlinear functions that causes the distortions or the harmonics. Okay, so it will vary, the output will vary linearly with the input. So it means that it reduces the nonlinear distortions. Next, reduces the effect of noise. So I told you, like, whenever the noise affects the amplifier, the gain will vary. But here the gain is constant and it is not sensitive to noise. So it indirectly tells that effect of noise is reduced. Effect of noise is reduced. Next is control the input and output impedance. Now, based on the requirement, the input and output impedances are judged. So, whether it should be minimum, whether it should be maximum. So, based on the requirements. Okay. So, according to the topology we design different topologies here. According to the topologies we design, the inputs and output impedances are changed or it is managed. Okay, so this is how you can control the input and output impedances. Next is extended bandwidth of the amplifier. That is, the range of frequency what we use will increase. So say for example, without feedback I am able to control the frequency of from 10 Hz to 100 Hz. This is just an example I am taking. So without feedback, that is negative feedback, I can control the frequencies from 10 Hz to 100 Hz. Suppose I am using the feedback now. If I use the feedback, I may be able to control the frequencies from 10 Hz to 1 kHz. Okay. 10 hertz to 1 kilohertz. It means that number of operating frequency got increased, right? Number of operating frequency got increased when I compared with these two. So this is what increase in bandwidth means, okay? So extend the bandwidth of amplifier. This is an example, or this is just a analogy how you can tell the bandwidth will increase. The next one is advantages of negative feedback. So most of the points here we have discussed. So it is a stabilized gain, the same thing. So the gain is stabilized. It will not vary even if there is some minute amount of noise or any sort of distortion is added into the circuit. Higher input impedance. These two are the very important property for an amplifier. So whenever I use negative feedback in an amplifier, it should always have these two properties. One is high input impedance and low output impedance. If you remember the op-amp circuit, what is the ideal characteristic of op-amp is it should have high input impedance and low output impedance. Okay, so the same thing here it reflects. It should have higher input impedance and lower output impedance. Increased bandwidth. So whenever I use negative feedback, the bandwidth of the system get increased. Reduces nonlinear distortion. I discussed in the previous slide. It will reduces the distortion which are nonlinear in nature. Next, it reduces the noise. Because the noise is reduced, the gain is stabilized and more linear operation. So these 2 points are one and the same, right? So if there is reduce in non-linearity, the operation is more linear. Okay. So these are the main advantages of negative feedback system. So that's all for today. Thank you for watching this video. If you have any question, you can write me back to my mail ID. Please like the video, share the video, and don't forget to subscribe the channel. Thank you.